We'll do a rerun with a 3 cluster analysis, right? So I'm again going to repeat a couple of steps. So you might have already done that. Supposing you're starting on a fresh day, then yes, you'll have to redo this again. So I'm saying USRS, and then I'm saying again USA is nothing but USA rest, right? And I have to determine the number of clusters. So again, the same approach: WSS allocation n row into USA minus 1, number of rows of USA into sum, and I'm saying apply function. Inside that I'm passing USA 2 comma var, and that's WSS. Now then I'm going for the for loop for okay, this is where we'll have to again use the code from here. So for I in 2 to 15 WSS box bracket I location. Just check WSS first. Allocation sum of k means, we're running a k means inside that we're passing USA. We're saying centers is equal to I, so you're running it iteratively, again the same approach, and then you're saying just give me the dollar within SS, yeah, and then just do a control A, control enter. Okay, there's an error. Okay, we have punched in 2 of these. Control A, right, that's done. So different values of WSS. Now just close this and we can come back to the console window, and here you can do a plot again in the same approach as you had done last time. 1 to 15 comma WSS comma type is equal to B, it's both a line and a point, and xlab, that is the x-axis label, is the number of clusters, and the y-lab is the within group sum of squares. Actually getting this thing over here, and again, although it's less over here, they've taken equal to 2 at 3. Most of the time it makes more sense to take less number of clusters, because if you have more number of clusters or segments, then you have to think of those many strategies on the type of data on which you're working. So let's name this as fit 8, and you're going to use the k-means over here with the data that is USA, and you're saying form 3 clusters, right? So that's what your cluster is, and then you can do a fit dollar centers to get the centers of the cluster. You can also do an aggregate. Now in this case it's a little bit different. Aggregate USA, so you have to say by is equal to list fit $8 cluster, and the functionality is mean. Once you're done with that, you will append the cluster assignment. So you say USA1 allocation data dot frame bracket USA, that's a object, fit $8 cluster, right? So this should be your data, right? So this is where the clusters have been allocated against the observations. Fine. I'm just going to close this part and try to plot this. So you can say class plot, and in that you can pass USA, that's the object, and fit $8 cluster, comma, color is equal to true, and shade is equal to true, label to 2, and lines is equal to 0. It should get a amazing graph over here. So this is how the clusters have been formed using the class plot. So you are basically not having any access. You see, this is component 1 and component 2, because there are more than 2 or 3 dimensions, and you cannot show it in a graph like that. So you're basically converting some of the axes and merging them into a component which reflects the overall effect of those 2-3 elements, and then you are trying to show that in a different dimension, right? So this is cluster 1, which has these states. This is cluster 2, which has these specific states, and this is cluster 3, which has these specific states. Obviously you cannot say that Florida is at this value or this value, because this is a component and not a true axis. Okay, now you can do a plot cluster wherein you can mention USA and fit $8 cluster also, wherein you might see that in this way. Right, so again it's doing the same thing. It's creating a discriminant component 1, component 2. So you're getting this patch of cluster, this patch of cluster, this patch of cluster over here, right? But yes, it's not in a way in which a human brain can understand, okay, these are the relative values, because those are missing, because you have transformed the data now. So if you want to compute the difference between these two, you can say cluster dot stat and actually get into both of them, and you can say fit $1 cluster, that was the previous one, and now the fit $8 cluster. Okay, if you remember, in fit 1 you had created not 3 clusters, but you had created 4, so the size is not matching, so it's not able to do the comparison. But had you given by this method and by that method same number of clusters, this would have been eventually able to seek out the difference between the two. Now we have already done how to determine the number of clusters. So what you need to do is you need to plot the within group sum of squares versus the number of clusters. The sharp decrease from 1 to 3 clusters with little decrease after that suggests a 3 cluster solution, right? But eventually, actually, if you see, the sharp decrease is from 1 to 2 as not indicated by the chart. The sharp decrease is not from 2 to 3, the sharp decrease is from 1 cluster to 3 if you go by the real chart. So analytics is not just about numbers and not just about graphical depiction, it's also about the analyst's perspective. How do you see that, right? So that varies, and basis analyst to analyst it might change. Sometimes it also comes from the background that finally the outcome of a cluster is to take a strategic decision. Say for example, you need to try to relate this with something like a BCG matrix wherein you have a cash cow, right? So there is something like a market growth and something like a market share. The market growth versus market share is a segmentation of the customer or the market. Basis that when you form some clusters, 4 clusters, you have a strategy which is defined for each of that segment or cluster. So typically, ideally, you go for 4 clusters if it is a business problem. If it is anything apart from that, then it depends upon the domain as to where you want to do clustering.